It's like really, really unfortunate.
Yeah, I hope that doesn't happen to me ever.
Yeah, same.
All right, we're live. So
Okay, great.
the homework seemed pretty straightforward this week.
Yeah, it's kind of plug and chug.
It's just teaching us how to use the two sample t-test, it looks like.
Yep.
Okay.
But I think the thing that took me the longest was trying to find which one to use, just because like it's technically the independent samples in the videos and stuff.
Yeah.
And by hardest, I mean it took me like 10 minutes. Oh wait, it's probably in that, of course. Awesome. I'm ready. I'm ready to start the quiz if you want.
Okay. Same here. I've already got the Excel spreadsheets open for the quiz.
Oh, okay, great. Let me open those two.
Okay.
Okay. Freshman dinner. Okay, great. All right, got it.
Okay.
Awesome. So, question 3. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply.
I thought it was the first one and the fourth one.
Yep, that's what I think as well.
I don't know if the mean is normally distributed. I don't think that matters. And then the population mean being greater than 0. The only thing that needs to happen is that the confidence interval needs to be greater than 0. So I think that's wrong too.
Exactly.
Question 4, the test statistic for a hypothesis test comparing two means with independent samples is a t-score, right?
Yeah. I don't know what an F statistic is. Is that the made up thing or?
Yeah, I think so.
Okay. Okay. I'm like, am I supposed to know what that is? Okay. Question 5. Two samples are independent if one, knowing which subjects will be in group 1 determines which subjects will be in group 2. So that's false. Okay. Knowing which subjects will be in group 1 tells you nothing about which subjects are in group 2.
Yep.
That's the second one.
All right.
Okay.
For the next 6 questions, use the data file dentist office bills. This data represents a simple random sample of dental bills at a dentist office in Idaho Falls and a dentist office in Rexburg. Let the parameter mean be the mean bill at the Idaho Falls office, and let the other one be the second one. Okay. Perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, which means we have the null hypothesis that they equal each other, and an alternative hypothesis that the Idaho Falls is less than the Rexburg one. Use a level of significance of 0.1. All right, I'm going to plug that stuff in.
Okay.
And it's a less than test, right?
It does say right there, yeah, it looks like.
Yeah? Okay.
Yeah, the null hypothesis is the equals. The alternative is that the U1 bill is the Idaho office is less than the Rexburg office.
Okay.
Yeah.
Cool.
So once you plug that in, just to test, make sure we did it. What did you get for your standard error of the mean?
46.706 and 46.206.
Okay, great. Got those as well. So
I got 37.996 for the degrees of freedom.
yeah, I did too.
Sweet.
So 7.996.
Okay, and then
No, I'm doing this. Okay. Sorry, my quiz last time wouldn't work, and it wouldn't save answers, and it didn't let me turn it in. So I thought that was happening again, but we're good.
oh, okay. That would
I
be
know we're good.
Hmm.
Yeah, super annoying. Okay, what is the sample standard deviation for Rexburg? So to confirm, Rexburg office is the second one,
yes.
which means standard deviation, I have 206.637.
Correct. Yeah.
Okay, great.
And then what is this test statistic? I think that's negative 0.434.
Yeah.
And the p-value would be 0.333. Triple threes.
Where's the p-value? You have 0.333?
That's what I have, yeah.
I have 0.6665.
What? Do you have the type of test set to less than?
Oh, no. Just kidding. Oops. I think that's the only thing that changes. Okay. Test statistic is negative 0.434. And then p-value. Okay, yeah, great. What is the correct decision based on the evidence? So the p-value is higher than 0.1, so we fail to reject, right?
Yeah, that's what I would think.
Great.
Okay. Suppose instead that you had used the alternative hypothesis that they weren't equal to each other. What is the correct decision based on this evidence?
Oh, that's just 0.666.
Oh,
So
okay.
it just doubles the p-value, which means it's still the same. You should
Okay.
fail to reject. That's oh gosh, I always forget. Evidence to say that the dentist bills between the two cities are the same, right? No.
Well, it looks like
There's insufficient
looks
evidence
like
to say that they're different.
yeah, it's 260 for variable one and 288 for the other one.
Mm-hmm.
So yeah, I think the first one.
But the p-value is 0.6.
Yeah.
And the alpha, or whatever it's called, the level of significance is 0.1.
Oh, I see. I see. No, you're right. It's the same because the null hypothesis is that they're the same, right?
Yeah.
Okay, no, you're right.
So then this alternative hypothesis. So let me double check. Hypothesis is that they have the same.
Yeah.
Negative is that they just don't. And so since we would, yeah.
Okay, so we have
So we don't reject it, which means evidence to say that they're the same.
Yeah, correct. Yeah. Sorry about that. I was jumping again.
No, you're good. Okay, so that's the fourth one. Yes. Okay, great.
The fourth one? I thought it was the third one.
Sufficient evidence. No, it's insufficient evidence.
And we have insufficient evidence that the mean dentist bills between the two cities are the same.
Yeah, which makes sense too because they're not the same. Which means we don't have enough evidence to say that they are the same.
Oh, okay.
Yeah.
I thought insufficient evidence would be if we rejected the null hypothesis.
I have it written down that we don't.
Oh, okay.
We don't reject it, then it's insufficient. If we do reject it, then it is sufficient.
Oh, okay.
I know. I've been really struggling with this rejecting, not rejecting thing, so I
Yeah.
went back to, with the videos this week, it went over it again.
Uh-huh.
Put it all down. That's what I have, at least. I mean, I guess we'll find out.
But yeah, I think, no, yeah, you're probably right there. I have trouble with that too.
It's like, it doesn't make sense.
Yeah. It's hard to, I don't know, wrap my head around sometimes.
Yeah.
Just write that down really quick then.
So what I've written down is if the p-value is less than the level of significance,
Yeah.
then you reject it. And if you reject it, you say we have sufficient evidence to say, and then you repeat the null hypothesis.
Yeah.
Don't reject it, meaning that it's higher than the level of significance, then you say you have insufficient evidence, the null hypothesis again.
Okay. Sounds good.
Hopefully. I think it's right.
Find out.
Yeah, seriously. Okay.
Next one. Sweet. Okay. For the next 6 questions, use the data file freshman dinner. This data represents the number of times freshman students from Utah and Colorado cook their own dinner in a month. Let U1 represent the mean number of times a month that a student from Colorado cooks dinner, and then the mean parameter 2 represent this mean for Utah students. You suspect that freshmen from Utah cook dinner for themselves a number of times, dinner for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis is that they're equal to each other and use a level of significance of 0.05.
Okay. So the alternative should be set to not equal to each other.
Yep, I agree.
Okay, cool.
Correctamundo. Okay, let me get these data points in. So
Okay.
do you have 2 more sample amounts from Utah than Colorado?
I do, yeah, and they're both 14.
So wait, you have 14 sample sizes from each one?
Oh.
I have a sample.
The 2 extras, the 2 extras,
yeah.
they're both 14 on the bottom ones.
Yeah. So should we just include them like up until 11 then?
Well, I think because they're independent, I think you can still keep them.
Oh, really? Does that mean our answer to the question earlier was wrong?
No, I don't think so. Which question would have been wrong?
3. Question 3.
Question 3. Let's see.
Because I put the first and the fourth one.
Oh, that's right. Have to be the same.
Do they? I didn't find anything in the text supporting that. I just.
Yeah, I don't think so either now that I think about it.
Let's see.
Maybe it's just. It might be the mean is normally distributed for each group then.
Okay.
Because that's what it's talking about. Yeah, I think it's the first and second one.
Okay, we can try that then.
Oh gosh, I should have read that better, my bad.
No, it's all good. Okay, so
for the test statistic, 0.845.
I'm still filling in my stuff.
Oh, you're good.
And then the What did you get? 0.845?
Mm-hmm.
Same here.
Okay.
Sweet. And then p-value, I got 0.441, and then I'd round it to 1. 441. Okay. And then we fail to reject again, right?
Or, 0.05.
Yeah.
Yeah, because it's bigger than that.
Mm-hmm.
Okay, determine a 95% confidence interval U1 minus U2. Difference between U1 and U2. Input your answers below.
The margin of error. So the margin of error would just be...
It's the T value.
Yeah.
Are they using the same data points?
I think so.
For the next questions. So, yeah.
Let's see.
Left.
I gotta look at my notes again to see. So for the margin of error, it's just, what's the formula again? Is it Z times the data point minus something else?
The margin of error is T, the square root of standard deviation for the first one squared divided by the sample size that matches the standard deviation plus the standard deviation for the second one squared divided by the second sample size. All of that's square rooted.
Oh.
So here's the
What lesson is that from?
13.
That's from lesson 13?
Uh-huh. Here, let's see if you can see it. Hold on, it's down here.
Okay. So I searched the lesson material from that. Was that in the video?
Yeah.
Oh.
Was in the video.
Yeah, because I didn't read anything about that.
Really? Like at all?
Yeah, it's not there in the lesson.
That's weird.
I should watch the video more. And if I search the page,
You watch the videos. It's like a faster, condensed version of
what you're reading. Well, I'm typing in margin and searching the page, and it doesn't even show margin was mentioned on the page. So
yeah, it shows because it was going over the confidence interval.
yeah.
The confidence interval is always that plus or minus the margin of error.
So can't we just take the confidence interval and then divide it by 2, and that's the margin of error?
No, because the confidence interval is the mean of divided by the it's the mean of number one, like one sample set, minus the mean of the second sample set. And that's like the thing. And then it's plus or minus the margin of error. And the margin of error is T times the square root of the standard deviation from the first sample set squared divided by the sample size.
So it's multiplied by the margin of error. It's not added or subtracted from the margin of error.
No, it is. I'll write it down bigger so you can see it better.
Okay.
So T Okay. Okay, so this is the margin of error.
Okay.
So it's t times the square root deviation of the first sample set, like the first group of information squared, divided by its matching number of like data points or sample size.
Uh-huh.
The squared standard deviation of the second set divided by the second sample size.
Okay, let me write that down. Just a second. What? Okay. See. First sample size. Okay. Okay, I got it. Thank you.
Yeah.
So,
and then the confidence interval.
Yeah.
X with the line over it of the first one is X with a line over the second one. It's kind of like that. It's plus or minus the margin of error.
Okay. And I also went back to lesson 10 because I remember that's when we first got a confidence interval introduced to us. And here, just a second. Sorry, just a moment.
No, you're good.
Yeah, I wrote down that the margin of error is half the width of the confidence interval. I don't know if that's right or not, but I don't know how else we'd compute. Like, it doesn't give us a standard deviation or anything for problem 16, so I don't know how else we'd compute it.
Well, I think for problem 16, and that's the thing that's confusing me, is it says up just before problem 12, it gives us the information, and it says this data represents number of times, blah, blah, blah. For the next 6 questions, use this data file.
Yeah.
So I think it's the information that's been plugged into the Excel worksheet.
Okay, so then we can get it from there. I see what you mean.
Yeah, we have the standard deviations, but we also just have the confidence interval.
Yeah.
So like I don't.
We could try. I don't know. What do you want to do?
Do
you want to try computing it?
Because I know that
Sorry, go ahead.
I was gonna say, yeah, try and compute it, and then one of us will turn it in, and then just see. Because there's only 3 questions left, so.
Okay. Let's see.
Especially with question 16, it's asking us for the margin of error.
Yeah.
And that doesn't give that the standard margin of error overall. It just gives like for both of them.
Yeah.
So like we would have to use the thing to compute it anyways, even with the Excel sheet.
Okay.
So I'd assume that's what it is.
All right. So let me know the answer.
Okay.
And I'll compute it too, and then we'll compare.
Okay. And we'll compare.
Yep. Standard deviation
divided by.
So then n is going to be different for both of them too.
Yeah.
Okay.
I think I've got it.
Okay. What'd you get for the margin of error?
For the margin of error, I got 0.451.
0.451. Oh, my phone. What the heck? I use my phone as my calculator and it keeps on turning off.
Yeah, that's so hard to do with that.
Yeah. Okay.
I can show you if you want to. I used my fancy calculator.
Oh, do you have a graphing calculator?
I did this.
Nice. Nice.
It literally that's great. You just put stuff in. You don't even need to.
Don't even need to
Around.
Oh geez, this phone. I don't know what it's doing to me. Yeah, too. What'd you get again?
0.451.
Okay, and you took that formula that you gave me, and then you took x2 minus x1 times that?
For the margin of error, I did 0.85 multiply by.
You're kind of breaking it up.
Yeah, my computer's funny.
Wait, so did you plug everything into that formula, and then that gave you the margin of error just by itself?
Because the margin of error, as it says on the thing, is just t times the square root thing with all those.
Okay, and then that's the 0.451.
Mm-hmm.
Oh, okay. Okay.
Yeah, that's just the standard. That's the error. It's not.
Okay. I think I get it. So are we gonna put 0.451 in for 16?
This is 0.451.
And then we'll subtract that from the mean, right?
Yeah. And so the mean, you do the mean number one.
Okay. So the mean for number one minus the margin of error, that's going to be the lower bound. And then the upper bound is going to be the margin of error. Second one plus the margin of error.
So,
but why doesn't that equal our confidence interval?
I'm looking at. That's like what the says.
What was that?
That they gave me in the video.
Hey, Ian, I can't really understand.
That's what it gave me. Not like
It's breaking.
214.
Sorry, I didn't understand any of that because it's so broken up. It's crazy.
Yeah, sorry, that was happening. Is it better? Is it better?
I heard that sentence. I'm just afraid I won't hear the next sentence.
Yeah. Yeah, I know. I think I need a new computer.
Okay. Well, I'm hearing you fine now. So, what were you saying?
So basically, the equation that I got from the video is not giving me the same answer as the Excel document.
Yeah.
So I don't know what's going on. I say we just use the bounds from the Excel document.
Okay.
But I know that's the right standard or margin of error because like that's what the video said. So.
Okay. So the lower one is negative 0.2. No, negative 2.214.
Yeah.
The upper one is 5.147. Okay.
You want to put that in or do you want me to first?
If you wouldn't mind.
I'm good. Let me just save everything real quick. Now that it's letting me save things, that's great.
If the margin of error is incorrect, I might know it could just be the width of the confidence interval divided by 2.
Okay.
I hope it's right.
So we got the last. Yeah, we got the last 3 wrong.
Oh, really?
Yeah. But like, that doesn't make any sense.
So was number 3 right then? Question 3?
But I think so. Yeah, number 3 is right.
Okay.
With the first 2 checked.
So that means that the sample sizes can be different and it doesn't matter.
Yeah.
But for question 16, that was wrong, huh?
Yeah, but I don't understand why.
And then the lower bound was wrong, and then the upper bound was wrong.
Yeah, so our lower and upper bounds were wrong, which we got from.
Yeah, that's weird. Did we put the right type of test? Like, does the different types of tests influence the confidence interval? No, it only changes the p-value. Huh. Just a second. Let me go back to the lesson.
Okay.
Reread the section on confidence intervals really quick.
Okay. Go look at that video. Okay, I'm going to show you what the screen thing says. I'm going to do a screen share really quick.
Okay.
All right, see this?
Yeah.
Like, this is what we did.
It's saying 1 minus the level of significance times 100% is the confidence interval formula. Do you think our mistake is that our confidence level is not at 95%? It's going to be less. Is that our mistake?
Oh, that could be.
No, but then it says the level of significance is 0.05, so it would be 95 anyways. Let me think.
Yeah. Plus, like in calculating the interval, anyways, that you don't even take the confidence percentage into account, anyways.
Wait a second. Okay, so the first sample mean minus the second sample mean. Did we do that? Did we not do that?
Yeah, I did.
Okay, so 16.667 minus 15.2 is 1.467. And then we take that number, but then 0.451 isn't even right. Right?
Yeah.
Second, let me.
So I think but that's the thing that I don't understand is like the standard deviation that the margin of error should be right, unless we did something wrong. Like.
Okay, Let me see. So it's going to be 0.845 times 3.42 over 12, right?
3.42.
Yeah, that's the standard deviation for variable one.
Oh gosh, I did the standard error of the mean.
Oh, is that where we went wrong?
That's why. That makes so much more sense. Let me change that.
Okay, and then make sure you get n right for each one too.
Yeah, I got n right. Gosh dang it, that's my bad.
No, you're good.
So it's 3.42 squared for variable 1, and it's 4.51. So that makes so much more sense.
I don't know why I didn't show that in the reading though.
Okay, great. So now we have that. Okay, yeah, they're the exact same.
Wait, what?
So
Error is still the same?
mean 1 minus mean 2. Like, so the variable 1, like, let me see. So, like, I'm going to share my screen again so it's easier to show. Okay. So, can you see my cursor too?
Yeah, I can.
Okay, so this minus this equals this.
Wait a second. Where's your cursor?
It's on
Actually,
the formula.
no, I can't see your cursor. I thought I
Oh, you
could.
can't?
Oh, there it is. There it is.
Okay. Weird. Okay, so this, like this half of the equation
Yeah.
equals this half.
No, it says plus or minus.
I know. But like what I'm saying is the answer I just got is
That's
that. Yeah. Is 1.467.
Oh, it says that happens sometimes. In the reading I read about that. If the confidence interval is 0, let me see.
Yeah, it's because 0 is within the confidence interval, I think.
If 0 is in the confidence interval, then it is plausible that the means equal each other, which means the alternative hypothesis would be true. That's what that means.
Well, then how do we have a different how do we have a different confidence interval with it still doesn't explain how we have a different confidence interval with the Excel sheet.
Yeah, see that one? I don't know. Wait. I'm just finishing the equation right now.
Okay.
So what'd you get for the standard of error then? I mean the margin of error, I'm sorry.
Margin of error, I got 1.46724.
Okay, because I got 0.7252.
How? What did I do wrong?
Because I took the square root of those two added together, which was square root was 0.7367. Let me try it again. My phone is really wigging out here for some reason. Yeah, so the square root of those two numbers added together, I got 0.858, and then I multiplied that times 0.845. I got 0.7252.
So when you did, what's inside of your square root?
So I got 3.42 divided by 12 plus 4.517 over 10.
Those are squared though.
Oh, those are squared?
Yeah, the numerators are squared.
Oh, shoot. I forgot to do that. That's okay. Sorry.
You're good.
Dang it. I have to redo all that. Okay. Phone is. All right. No, I trust your calculations. My phone is like turning off and on by itself. So I don't know.
You're good. I'm just really confused.
So would that mean? So the last three would be 0 then?
Well,
No, the margin of error would be 1.467, right?
the
And then
margin of error would be, yeah, the margin of error would be 1.467. And then the lower bound would technically be 0, I guess. And then the upper bound would be 1.467.
yeah. No, wait. The lower bound. So we get 1.467, and then for the lower bound you subtract it, and then for the upper
Bound, you'd add it.
Yeah, wouldn't it be double then?
Oh, yes. Yes, it would. That's correct.
I'll try and submit that, and we'll see.
Okay.
You need to fill in all the other answers before I submit this one, though?
Yeah.
So we don't lose our answers?
I was just writing them down.
Oh, okay.
You can get them from you before you do it, though.
Okay. Let me know when you're ready.
Okay. He gives us 2 submissions.
Seriously.
Beautiful.
I hope we get it right.
I do too.
We'll see.
So 3 is the first 2, right?
Right.
4 is the t-score.
Mm-hmm.
5 is tells you nothing about.
Mm-hmm.
The 6.
37.9696.
966 or 996.
996. 37.996. And 7 is
Okay, what's 7?
206.637. And then 8 is negative 0.3. Sorry, it's negative 0.434.
Okay, 9.
And then 9 is 0.333. 10 is fail to reject the null hypothesis. 11 is the last one. We have insufficient evidence that the mean densest bills between the 2 cities are the same. 12 is the second one, not equal. 13 is 0.845. 14 is 0.411. 15.
0.411, you said?
Yeah. And then 15 is failed to reject.
Okay.
16 is 1.467, and then I'm sure you've got the rest. Should I submit it?
Yeah, you submit it, and then we'll see what happens.
We missed the last 3.
Again?
Well, and question 13 was not 0.845.
Wasn't?
No. And question 11 was wrong too. It's not the last one.
What? I got those were all right in mine though.
Really?
Yeah.
Huh. Because I put we have insufficient evidence that the mean densest bills between the 2 cities are the same.
Yeah, that would work. That would be the answer because it. Starting to question. What the heck?
Dang it.
I'm super confused now. So for. Well, what the heck is it then?
Yeah, I don't know.
Okay. Okay, margin of error. So 13 wasn't 1.467?
13. Wait, are you talking about 16?
Sorry, yeah, 16.
No, it's not 1.467.
What the heck is it?
I don't know. And you typed in the confidence interval before and that wasn't right?
No, I did the.
Did you type in negative 2.214 and
I think so. Yeah, I did. And that didn't work. What the heck? Doesn't make any sense. Okay, so which numbers were wrong? Which questions did we get wrong? Which questions did we get wrong again?
Oh, hey, you're back.
Sorry.
Very good. We got 11 wrong. We got 13 wrong. 16, 17, 18.
Okay.
But when I look in the feedback, it says the answer in SPSS is slightly higher than in Excel. So the answer given is the average between the two results.
For which one?
17 and 18. Well, 16 through 18, it says that.
It says the answer in Excel is slightly higher than that given in the other one. So it's
Slightly lower and then slightly higher, yeah. So it's the average between the two. I've never used SPSS, and so I don't even know.
I don't even know what that is.
It's like the other program for doing statistics besides Excel.
Oh. So the answer is the average between the two. Are we supposed to be doing it in both?
I don't think so. Just a second. Oh, I think I realized what we did wrong. Just a second. P-value. Actually, never mind. Looking in the instructions, and it shows that the okay, so back to 13. That's for the freshman dinner. That's the one we're doing. 0.845 is not it. I don't know why that's not right. You said it was right for you, though, right?
I'm like doubting myself now.
Huh. What the heck?
Because like it says the last two are just 0.5 of a point each. So I'm thinking maybe I accidentally skipped over 13.
Oh.
That freshman dinner.
Well, I mean, what else could T be? Like, would we have to compute it by hand?
I guess we could.
You know the equation for T?
Yeah, but not. It didn't give us an equation for this type of problem. So, so it said it's the average between the two.
I guess.
So I guess we could compute the T for both and then average it.
Well, it's saying it's the average for using SPSS in Excel.
Yeah.
So?
That's stupid. Why doesn't he just make...
Yeah, I don't know. I don't think we even have access to SPSS.
I think you have to like buy it or something.
Jeez.
This is making any sense.
Yeah, I'm not understanding it.
He's right there. That's so stupid.
Okay, so the t-score is going to be the sample mean minus the actual mean over the standard deviation divided by the square root of n. What I got.
Oh, okay. Yes. I do have the t-score. Yeah, you're right.
Except we're not given the actual population mean, are we? Is that?
I think we are in the Excel sheet. Yeah.
We are?
Yeah.
Which one is it?
It's in the variable 1 and variable 2 box. It's next to the standard deviation.
Yeah, but which one do we choose?
So for the t in this one,
Mm-hmm.
it's x. Here, I'll just go to it in the video, and then I can show you. Let's see, where is it? Might be in the first video. Okay, 1 second. It's in the first video.
What's up with having stuff in the videos that's not in the reading?
I have no idea. What's up with the thing that he gave us to find the answers, not having the answers?
I know.
Okay. I'm gonna do a screen share really quick. Screen share. I'm gonna do this. Okay. So it's really, really hard to see, but it's this.
Okay. Oh, geez. Yeah, that is really small.
Yeah, it's horrible. So what I think it is it's the mean of number 1 minus the mean of number 2 minus the u thingy of number 1 minus the u thingy of number 2.
Okay.
And then all divided by the square root of standard deviation 1 squared over n1.
Which is
Plus,
exactly what we used to get the margin of error earlier.
it is the margin of error like equation, and that's the thing that I don't understand.
Well, without t, it doesn't have t multiplied times it.
That's true.
So okay, but then where do we get u1 and 2 from?
So I remember if I'm the u thingy is the mean of difference. So I think that's in that thing as well.
What, the standard error of the mean?
No. Yes.
Oh gosh.
I think so, yeah. Because I don't see what else it could be.
Let me check real quick.
Okay, I'm gonna try it. Let's see. So we have 16.667 minus 15.200, which is all still subtracted by 0.987 minus 1.428, all divided by standard deviation of 1 squared, so that's 3.42 squared divided by 12 plus 4.517 squared divided by 10. So let's see how this works out. So we have
Which video did you look at?
that one is in the first video, but I watched both.
Okay. Because I don't know if that's right. Let's see.
And I'm not even 100% sure it's right, but like that's what it's so small that.
Because x1 and x2 has got to be something else. I don't know. I think the u1 and u2 is what the mean is given to us right there. And then x1 and x2 I think is something different.
Oh yeah, the UD is what the mean of difference is, not the just the U thing. You're right. Well, what are x1 and x2 then if they're not the mean?
That's what I'm trying to figure out real quick.
We also stated the known alternative hypothesis. We computed a test statistic, and then we also got a degrees of freedom as well. It's a one-sided where we dealt with matched pairs. This is how we define the known alternative hypothesis for matched pairs. Right? Here's
Oh, I see where you got the, if we reject it, we have sufficient evidence. If we don't reject it, we have insufficient evidence.
Yeah.
Okay, just a second.
See what I mean? Which means that other one should be right.
Yeah.
so there's going to be 6 steps. 6 steps that we'll be doing with independent sample, meaning the population mean of 1 is equal to the population mean of group 2. The alternative is that the population mean of group 1 is not equal to the population mean of group 2 if we're doing a two-sided test, or the population mean of group 1 is greater than the population mean of group 2, or population mean of group 1 is less than the population mean of group 2. Depends on the test whether we're doing a two-sided test like we're doing here, or a one-sided test, or a right-sided or a left-sided test. Then steps 2 through 4, we do the same thing. We compute a test statistic, determine degrees of freedom, and get a p-value. This is the formula for getting a test statistic, but basically you'll be using software, whether it's Excel or SPSS, to get your test statistic. But the same last 2 steps are the same. We either reject the null or not. So if the p-value is less than alpha, we reject samples. So both of these examples are on the online text. This is a children group online text.
So does he work through a problem with you?
Say that because it's always suffices.
Yeah, eventually.
Example of this software.
But it doesn't like give you any of the data for it. Like you can't do it with him.
We're going to use the bottom row. Now there's 2 rows. The equal variance is assumed and not assumed. Suffice it to say that because it's always right to use equal variance as not assumed, we're going to use equal variance as not. And this is where we get the test statistic, degrees of freedom, and our p-value. Now for SPSS, this is our, if it's a two-sided test, which this problem is, then we would, this would be our p-value. So this is our test statistic, degrees of freedom, and our p-value. Okay? And so now, first of all, if we look at this 1.455, that means that our result is 1.455 standard deviations away from the null hypothesis. Would this be a rare event or an unusual event? Well, that probably isn't, but the way to check it ultimately is the p-value. Okay, our p-value is 0.147. Okay. So,
Yeah.
but now to our level of significance, this is where we ultimately check to see whether or not it's an unusual value. Since our p-value is greater than what is significance, 0.1, we can stop the recording here. Do the six second. F alpha equal to cardiovascular.
Wow, I didn't find anything in the video talking about what X was.
Neither did I. And that's the thing, like in the video, he's like, do these three with the, software.
Yeah.
Hold on one sec. Hello?
Whether it's Excel or SPSS.
Not much, just doing homework. What's up with you?
But the same last two steps are the same.
Not much, I'm just doing homework. What are you up to?
P-values less than half we reject.
You put it on the table. Could be.
What if we just did the equation without even thinking about the other x's, you know? If we just did it for u, you know?
Yeah, that's basically the margin of error without a t. But we got the margin of error wrong, so it's not like we have anything to lose.
Gosh dang it. So what if we just take what if the confidence interval really is what we have there? But it's stupid because t is wrong and we plugged it in, so I don't know what else it wants us to do.
Yeah, I think what we should do is the test statistic, I say we leave it as 8 point. Maybe you talk to Sam for me. Hey, one sec. Okay, so I say we just kind of leave it because that's what the app says. Like,
yeah, I don't know. I don't understand why that would be wrong.
It says. And then, like, we even have the right p-value. And then for 16, 17, and 18, like...
Yeah, the p-value is right, so what the heck?
I don't understand how we can have the right p-value and the wrong everything else.
Yeah.
I put it in the bag with his frosting. I say we just put in the stuff that the Excel has, and then I'm gonna write him an email and like.
Well, it's asking for the test statistic. That might not be the same as the t-score. Yeah.
Do we have to plug the t-score into the applet?
Oh, you know what? That could be it.
Because that's how you get but that's the p-value.
But maybe in this situation, it'd be the test statistic. No.
Seems legit.
Oh, this is frustrating.
Yeah, this is really annoying. Plus, I don't even know how you would do that because in order to plug it into the t probability statistic, you need the number of degrees of freedom, but we have 2.
I'm looking in the homework right now, looking at test statistic when it comes up. It says the test statistic is 23. Yep, that's T. So I would just email him and say, like, why is this not working?
Yeah.
All right. Well, I don't know. I'm just gonna resubmit it, I guess.
Yeah, I'm gonna just do that too.
Here, just a second. Do you want to help me out? Which ones are which?
Yeah, I got you.
So I'm on number 5.
Number 5.
Number 6. Sorry, number 6.
Let me scroll up there. Oh. Okay, number 6 is. Sorry, number 6 is 37.996.
Okay.
7 is 206. 0.637.
Okay.
8 is negative 0.434. 9 is 0.333.
Okay.
10 is fail to reject.
Then 11.
Apparently we got 11 wrong.
So I think it's got to be the other insufficient evidence one,
Okay, we'll do that.
since we failed to reject.
Yeah.
12 is they're not equal to each other, right?
Yeah, are different. Yeah.
And 0.845. I'm going to put in
Yeah.
0.845. Maybe that might make a difference.
Yeah, maybe. P-value is 0.411.
Okay.
And then fail to reject. And then whatever the heck you want.
What is the margin of error? Here, try this. Let's see. Just try putting the. I don't even know. I'm just gonna take the width of the confidence interval divided by 2, and we'll see if that works. I don't know what else to do.
Yeah, that's fair. It's a good idea too.
But I mean, gave the equations in the videos. I just don't know why those didn't work.
Yeah, that's what I'm getting. That's like, it's really making me mad.
Yeah. And the T score, like, okay, I don't even know. He gives these complex equations, and then he's like, "Don't worry about it. It's in the Excel spreadsheet." And then it's like, "Well, what happens when that fails?" Like, all right. Well, I've got to study for my next group meeting here at 8. I've got 2 group meetings today.
All right. Well.
Hey, I got 89.47.
You got what?
I got 89.47. Here, wait, don't submit yours. I got the margin of error right.
You did?
Yeah.
Was it 3.618 or 681?
Yeah, it is.
What the?
So that means maybe we can figure out what the upper and lower bounds are based off of that.
Oh, yeah.
It's going to be, the margin of error is going to be plus or minus the t-score. Is that what it would be?
Well, according to the equations that have been working so well so far.
Yeah.
It is x1 minus x2 plus or minus the margin of error.
Plus or minus the margin of error. Okay, yeah. So it's going to be 16.667 minus 15.2 and then plus or minus 3.681.
Yeah, let me try it.
Try that, whatever those numbers are.
Okay.
At least I got a B+. I'm happy with that.
Negative. It gives us the thing from the applet.
Yeah, I got 5.148 though for the upper bound. And then
did you?
Yeah, then the lower bound is the same though. So I don't know. So stupid.
I'm so done with life.
Dude, this is retarded.
5.148. Yeah, okay, that's what I just got too.
Put that in the upper bound. Maybe that's right. Who knows? At least I got a B+.
Yes.
I'm gonna email the teacher on this one and say, what are the right answers?
Yeah. Can we give us access to that again and let us look at it? He's been pretty good too. He's been willing to help us however we need, so he's been good. Okay. Okay, we got 13 wrong still. Test statistic that we got from the app.
Yeah, I know, I saw that.
And then dang it. I got 16 right again.
Yeah.
With 17 and 18 are wrong still.
I don't know. All right, well, I'm gonna post this this video and then I'll email him and see what it actually is.
Okay, yeah, I'm gonna email him too and just say, hey, I know Andreas is emailing you, but I want to know too.
But I'm just curious, what is it?
Well, yeah, and we're gonna need to know eventually how to do it.
Yeah,
so.
yeah, true. All right. Well, thank you. Yeah. See you next week.
Yeah. See you next week.
Bye.
Bye.